Alright, hello once again. This is Jeff Scott of Rankin Technical College, and I'm writing some Java code for you based off of the textbook we have from Tony Gaddis, Java using Early Objects, 5th edition. And I'm going to do something a little out of order here. I just felt like it, so I'm going to do a File, New, Java Project, and I'm going to call this Chapter 15 Recursion. I'm just going to jump right to Chapter 15. Okay, and what I'm going to do is a Fibonacci number program that I did mention in the tapes, but if you don't watch the tapes, just so if you've never seen the Fibonacci numbers before, they go like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, I'll go up to 100 here, 55, 89, we'll go up to a little more than 100, 143. What you get with the Fibonacci numbers is you add two together and that becomes the next number. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 and 13 is 21, 21 and 13 is 34, 34 and 21 is 55, 55 and 34 is 89, 89 and 55 is 143. You see the pattern, hopefully. So I'm going to write a recursive, very short, it's only about 25 lines or so, program. So I'm going to come in here, and since it's Fibonacci, I'm going to add a new class, and I'm going to call it Fibonacci. ACCI, and we will have everything in main, so I'm going to add a main. All right. Do my little cleanup that I always do here. And add my comments. All right, now I'm ready to rock and roll, as they say. So, I'm going to prompt the user. So I'm going to say here, system.out.println, please enter the number up to which the Fibonacci number series is to print. Okay, so that'll just print right on the screen like that. All right, int number, I'm going to do this a little bit different just so you can see it. All right, so int number equal new scanner. I'm going to get an error message, so I've got to come up here and import java.util.scanner, and let's put our comment in as we usually do at the top here. This is the, I'll just say X because I don't know what it'll be. Java program. It uses recursion to print Fibonacci numbers based off of chapter 15 of our Gaddis Java book. Okay, so we're down to here, and I'm going to say here, excuse me for just a second, let me get my stuff together here. So now I'm going to say here, int number equals new scanner system dot in dot next int paren. What I just did there, so you know, and I got to see why I'm getting the error, but we'll figure that out. System.in, I think, has to be in parens. Yeah, the paren has got to go here. That should fix it. There we go. All right, so we're telling it to create a brand new scanner object, and that scanner object is going to hold the number that we enter right there. So I did what's called chaining. I combined a couple things together here. The system.in with the dot next int. All right. Then I'm going to say int comma num, and that's a weird name, but you'll see why I'm using it in just a second, equals number minus 1. Because this made me think of something, and by the time you watch this, I might already have said this in a different lecture. So int LCV equal 1. And actually, I think we should start it at 0. We'll see. I started it at 1 when I did it before. So for, we've already initialized our loop control variable, so we don't need anything in there. LCV, while it's less than comma num, which is number minus 1. So if I choose my number to be 10, then that number minus 1 is 9. So why didn't I just say number minus 1 here instead of doing the calculation? What if I was doing this a million times? If the number I enter there is a million, it's going to do this, and it's going to figure out that it's 999,999 and plug that in there. But if I do it number minus 1 here, literally it has to do the calculation. Even though it's the same calculation, it will do it a million times. Even though computers are unbelievably fast, why waste processing time and processing power doing that? To me, that makes absolutely no sense. So LCV plus plus. Begin, end. Okay, so we want to do this. What's in here right now, we want to do it for as many numbers as we have. System.out.print. And it's going to give me an error because I'm going to call Fibonacci, which I haven't written yet, Fibonacci recursion. So I'll get an error on this. And I'm going to pass it in LCV plus comma space. Okay. That's it for that. So I've got to write that routine. So I've finished with main. So now I've got to write public static int. Make sure I've got the exact spelling here. Int number. Fibonacci. Right now it's giving me an error because I'm saying it's returning an int and I don't have anything returned in there yet. So if if the number is equal to 1 or the number is equal to 2, so if either one of those are true, I've reached the end of my series. So I just return 1. But if that's not the case, all right, if that's not the case, then I want to return Fibonacci recursion of number minus 1 plus let's put another paren here. I'm way over parenthesizing, but that's okay. Oops, minus 2. Semicolon. All right, now what's missing here? I need another paren right there. That actually should be the entire program. So before we decompose it, we've got here int number, resource leak. Closable value is never closed. Oh, okay. I don't know if it's going to let me close number or not, because it's an integer. Close. Can I say number.close? See, I don't think it's going to let me do that. I'm just going to leave that close out of there, and I'm going to live with the warning. All right. So please enter the number up to which the Fibonacci series is to print. All right, we'll say 15. Oh, overflow error. I think I'm in an infinite loop. So let's stop that. So I screwed up someplace. And I've got my program here, and I ran it before, and it worked just fine. So take it from the top. Import java.util.scanner. Public class Fibonacci, public static void main, system.out. That should have been a print. That's the first thing. Please enter the number. Okay. Int number equals new scanner, system.in.nextInt. Okay. Comma num equals number minus 1. Okay. LCV. Oh, I know what the problem is. Okay, we'll fix it. Okay, equals 0. I missed this. So we're printing out everyone but the last number here. So after we fall out of the loop here, we have to print out the last one. So system.out.println, and that will be the last one. So it'll be this. Oops. Okay, that should fix everything. Hopefully, now it's giving me an error. I think I'm missing an ending. There we go. All right, let me just try to run it again. Again, enter the number, 15. Still is giving me a Stack Overflow error. It does not like line 33. All right, well, let's check out line 33. Return this. Doesn't like that return statement. Let's check everything that's in here. Okay. System, the print line, yeah, all that's okay. 4 LCV less than or equal to, comma num, LCV plus plus. What this is going to do is it's going to print out every one of them with a comma after it. Then once it kicks out, it's going to print the last one. And it won't have a comma after it. All right, if number equal 1 or number equal 2, return 1, return Fibonacci recursion, number minus 1 plus Fibonacci recursion, number minus 2. That's all correct. Let's see if I fixed it based on those errors that I had previously. In fact, before we do this, well, we'll put in there 10. Where to put that 10 now? No. So let's come in here and let's save everything. And then we'll come back and we'll rerun it. Okay? 10. Still getting the same exception thread in main. This is a good time for me to clear this. I'll go back and I'll take a look at all of my code. What's nice is I can see almost the entire program from right here. So I'm going to pause, and when I come back and figure out what the problem is, then I'll finish with the lecture. All right. I guess I started this up again without realizing it, but I've gotten this to work. So let me tell you quick what I had to change. I had started my loop control variable at 0, and it had to be started at 1. And 0, which is the first Fibonacci number, I had to hard code that in. So notice now if I run the program, stop, get that out of the way. If I run the program and it says, please enter the Fibonacci, let's get the first 50. All right, and that's pretty big. So let me stretch this out. So you can see, there are the first 50 Fibonacci numbers. Now there's all sorts of stuff we could have done in here. Instead of, for instance, what probably would have been a nicer thing to do would have been to use a print line here instead of a print and not have a comma, not have to worry about that. So put a print line there. All right, which means I won't need this, which means that I don't even need this comma num anymore. So this says, well, it's less than or equal to number, semicolon. And I don't need to print out this last one because I already am. So I'm cutting down the program size too. And again, that'll be number. And so will that. And so will that. Now, hopefully, at least, this is going to look a little bit nicer. We'll see. Let's save and let's run it again. All right, so I'll say here the first 25 Fibonacci numbers is what I want. All right, so 0 plus 1 is 1, 1 and 1 is 2, 2 and 1 and 2 is 3, 2 and 3 is 5, etc. So it appears as though it's working. All right, now let's go back and decompose and look at the program. All right. Again, this will be like the 15th, the 20th, whatever program. It uses recursion to print out Fibonacci numbers based off of Chapter 15 in our Gaddis book. We had to import this, and that is used for our input variable. Okay? Our class header, our curly brace, our method header, our curly brace. Then we've got our variables here. So first we prompt the user. Remember this line right here that says that, that's the line that comes up on here. Not sure why I got negative numbers there, but let's try this again. Let's just try the first 10. All right, so there we go. That please enter, that's this. All right, so I put in 10. All right, loop control variable is 1. I hard coded that 0 in there because it wouldn't print otherwise. Okay? All right, so as long as LCV, which is 1, as long as it's less than or equal to 10, then we're going to call the recursion. And what it's telling us in the recursion is if the number is down to 1 or 2, just return 1. Or if the number is 1 or 2. All right, just return 1. And that's what gives us basically this. Otherwise, it's saying, okay, whatever this was, add to it the one previous. So 1 and 1 would give you 2. 2 and 1 would give you 3. 3 and 2 would give you 5, etc. So it's using recursion. It's calling itself. Recursion is the act of this calling itself. And so it'll call itself recursively, but when it reaches a certain point, it will return. And when I say it will return, when it hasn't reached that point yet, it returns by calling itself again. But when it reaches, for 1 or 2, it returns 1. But literally, it gets to where There's nothing else to add, and it knows that it's done. All right. Again, the only problem that I have right here is this, and I don't know, it says that. I don't know how to fix that, to be honest with you. Okay, they want me to set it up like this. And I can do that. I have absolutely no problem doing that. I don't think it's going to let me copy it, though. So they want me to say scanner keyboard equals new scanner system.in. Whoops. Number equals, how did they want that done? Yeah, I know it's never closed. I'm gonna try to use what they suggest. Add suppress warnings resource to number. Add it to main. Oh, I wish I had it back. There. Okay, so I want to say there, I've got that. Int number equals scanner.nextInt. And int LCV equal 1. No, why it still doesn't like something here. I think these may have to be, this might have to be static. Cannot make a static reference to the non-static method nextInt from type. Legal modifier, only final is permitted, so I can't use that one. Let's go back to the way it was. Wish it would let me take this and copy it. Copy? I don't think it's going to, though. Oh, I did. Hot dog. So that was it here. Cancel. Just. Okay, it wants me to do this. Right? Now that I've done all this, now at the end of the program, okay, before I return, I can come in here and by the end of our loop, I can say scanner dot close. That remove that warning. All right, so by trying to cut this down from 2 lines to 1, I actually made it worse. So let's save. Let's try to run it one more time. We'll ask for the first 15. Let's move this up so we can see it. All right. Oh, I got to remove that comma. 1, 1. It all looks like it's okay to me. So we're putting out that 0. I no longer need that. I wonder if I can just print out the number 0. I don't know why it wouldn't take that. Just the number 0. But we'll see. Again, we'll ask for the first 25. There's the 0, 1, 1, etc. And there we go. So again, that was fairly quick, but you saw how a routine could call itself recursively. Okay? So when I come back, I'm going to go back into order again and come back with chapter 6, which I will do shortly.